All right, here we go. For the SDL part of this, the first thing we need to do is link it up. So we'll go into properties. We'll go into the directories here. You're going to include the SDL directory. Hopefully you remember that from before. If not, just type C:\SDL2\include. Same thing with the lib folder. We go for x86. That's going to have to match. That means 32-bit. That's what we're doing for the libraries. The next thing we have to type. What?
None.
You're going to type SDL2main.lib, SDL2.lib, SDL2_image.lib. And you can also do SDL2_TTF.lib as well. Lib. That's for the font. I don't know if it requires that, but.
Oh man, I'm actually going to watch the
There's those. I've already done this. This is on video. So it shouldn't be too hard to get that far.
Is that SDL2.main or just SDL2main?
There's no dot in main.
So any include directories is C SDL2 /include what? No.
There's no backslash.
And the
You can navigate to it. There's nothing inside the include folder but header files.
So nothing goes into the include directories.
Look, you're going to click on this, include directories. You're going to click on edit. You're going to click on the folder. You're going to click on the ellipses. You're going to navigate to the C drive, to the SDL2 folder, to the include folder.
Okay.
Just like that. Same thing with the library. You're going to go into the lib. It's one more deep because you have to choose the x86. And that goes right there. Okay. Are we ready?
No.
What?
That's all I need to know.
Alright.
I think I forgot to set my console, but you should know how to do that for sure.
Why does 86 mean 32-bit and 64 is just 64?
Because Intel invented the 32-bit and they decided to call it x86, and AMD invented the 64-bit and decided to call it 64.
That's stupid.
So in other words, AMD had the actual logic computers.
I don't know
We're
why.
just like, we don't care, call it 86.
I don't know. There's some reason they call it x86 architecture. Alright, everything should be linked up now. If you haven't done this already, you need to dump the DLLs in your project. The easiest way to do that is right click on your project, open folder in File Explorer down there at the bottom. Let's head over to the same directory, PC, C drive, SDL2, lib, x86. Click type. Type up at the top. That moves everything, all the DLLs together. You can just select them all with Shift and the keyboard, Control C, and then hit back to your project, and dump. there they all go. Now, for the actual code, we need to set up a few things. Looking at the lab here, it says we're going to have this base class called object, and it's going to have some SDL variables in it. It's going to have the RGB color, it's going to have a texture, a rectangle. Those are SDL things. So if we're going to need SDL things, we're going to include SDL. SDL.h and SDL image.h.
What's the header or the object header?
Wait, this should be objects header. My bad. Object.h. No, good call. Right after pragma once. Pragma once, if you don't know, when you include files like object into other files and the compiler tries to compile this is basically, include is basically a copy and paste operation. But if it's already included and compiled that file somewhere, this basically tells it, hey, don't do that again. You've already got it. It's an efficiency thing. Also keeps your program from compiling into weird loops. But so leave the pragma once there and make sure it stays there across all your header files. Or you can do the lock thing if you've been taught how to do that, where you like, if not defined, define that thing. That's exactly the same thing. You can do that instead. That's actually better than pragma once. Pragma once is Visual C++, whereas the pound defines are general C++. That works across the board. Okay, so SDL's been included here. We can start adding those objects that we need. We know we need, let's see, it says we need variables for speed. You guys should already have that though. Angle. What else? RGB color. So that's going to be an SDL color. This color. And the texture. SDL texture. Underscore. Texture. Textures are always pointers. They have to be on the heap because they can get really large, so it's always a pointer. Call it text, call it texture. SDL underscore rect, that'll be the rectangle. The rectangle is just a structure with 4 integers in it, so that can stay on the stack, that's fine. We're going to need constructors. We've got a blank constructor here. It says you need a 3-argument constructor, right? Accepts the texture file, the starting position. We don't have position on here, do we? So I took out that vector. Let's hold off on position then. But we can do one with the texture file. So how would I do that?
With a string, make one that has the texture of a string.
Yes. So what is a constructor? It's a function that has the name of the class, and it's going to be executed when the object is created. So yeah, it would be a string, and you can just put something like texture name or whatever. I don't have string, so I'll have to include string. String's part of the STD namespace, so I'll go ahead and throw that too. Again, putting this in a header file is highly frowned upon by some people. Nothing wrong with it, just frowned upon for style. How are we doing? We good?
Yeah.
All right. What else? What's next? All right, through inheritance now, everything extended from object has all of these things. Our player, did our walls extend from object? I think they did. They have a speed, they have an angle, they have a color, the texture, and a rectangle. All of this stuff has been applied to every class that was derived from object. Am I missing anything? All right. At the bottom down here, it says in main initialize SDL. We're going to create a window, set the window accordingly, create a renderer, create an instance of these things, a main loop, pull event loop. We're going to clear the screen in dark gray, draw all of the objects, easy cheesy. So main, pound include, well, we know we're going to need object. What am I missing? I feel like I'm missing something.
Where the update in the Dropbox.
Well, I declared them. I never defined them, but they're there. We can define those right now. So we go to the source file. Oh, we can fill this out too. So our texture pointer, which I called text, is going to equal image load texture, and then we give it the renderer and the file name. Now I passed it in as a string, so I'll have to use that C function or that C underscore str function to get the actual C string out of there, but that's not unbearable. All right, so what do I learn here? What is that telling me?
There is no renderer.
There's no renderer. I'm definitely going to need a renderer though, right? So how do we want to handle that? We have lots of options.
Put the object header to be.
What?
Put the object header.
Put the renderer in the object's header? That would be difficult.
Well, it says to create renderer in main.
Yes. Yeah, let's just stick with that for now. Let's say we have to put it in main. How do I get it here? How do you get information into a function? How'd the file name get there?
For some reason.
Okay, we can do that. We can pass it in.
It's not showing. I can't find it. Yeah, it says I created it, but I can't find it in the folder.
We could do it this way, or we could put one in our object class, and I think I like that better because then it's everywhere in objects and all their descendants. We can put one here, and we'll just have to make sure we set this pointer to point to the one we create in main, and then we don't have to pass it around. So that's the other option. Another option is to make the renderer global, and then it's just available everywhere. But we haven't covered global across multiple files yet. That's later. So what do you want to do? Pass it in or set this guy?
Set that guy.
Okay, we'll do that. We'll go back to object then. If we're going to do that, we don't need this. It's already in our class. Our function's happy now because it thinks it has a renderer. It doesn't know the pointer is pointing at null, but we'll fix that later. Or pointing at garbage, I should say. So this initializes our object. That does the texture. What else needs to be initialized?
The starting position.
The what?
The starting position.
Yeah, we'll have to do that. We don't have anything for that right now, but we'll leave a comment. It'll be kind of our to-do. Something else needs to be set though. This is not hard. You just go back to your header file and look. We got some things here.
Color. Oh, easy to set.
Color?
Yeah.
I'm not sure what that's for, but we could set it. The default color. Color equals, and you can put whatever you want in here. RGB goes from 0 to 255. So red, green, blue. We got some red, green here. That's some sort of yellow, and I think that's yellow. Anyways, alpha at 255. We're not using blending, so it'll automatically be 255. But we'll set it at 255 in case we want blending later. Our color's set. I don't think we ever use it, but it's there. What else? Rectangle, that's the most important one because we cannot draw a texture if we don't have a rectangle. So, rectangle. You can use query texture or you can just hard code some values in here. What's the order? You don't have to do it that way either. You can just do a dot H. You know, my height is 20 and rect is 20, or W is 20. Where do we put it? Hmm? 100? For a moment. We can come back and change it later if we need to. That's fine. That'll bring it 100 down and 100 over. Well, that's the top left corner too. Remember, with the rectangle, you're working with the top left corner when you're setting the position, not the center. All right, that's the rectangle. What else? In the constructor? In the update. All right, we'll get to that later. This is probably good enough for now. It would be wise to set like speed to something that isn't garbage, and angle. Also, good to initialize everything. You don't want stuff floating around at garbage. The update to do, set key controls, and what else? Draw. Draw just gets one function call. Do you remember what it is? Nobody remembers? I can't remember the enum. What is it? Yes, I don't know why I want to put render there, but yeah, SDL flip none. There's our basic draw call. We're holding off on key controls because I haven't showed y'all how to do that, I don't think. We didn't do keyboard input. Okay, so
There's in one of your videos, scan code.
Yeah, it was like, I guess you had it for like a previous semester, SDL2 stuff, you did it in the video.
yeah, I've done this a gazillion times. Anyways, okay, we'll come back and do that in a little bit. Let's get it on the screen first, and then we'll put in controls, because if it's not on the screen, then we can't move it. At least we won't know if it's moving. Alright, so back to main. We're going to include object, as a string. Int main. Remember, with SDL, main is macroed, so you have to provide those two arguments. Int argc, that stands for argument count, and char pointer arguments. This is so if you want to launch your program with flags, you can do that. They come in as arguments, string arguments. Okay, first thing to do, initialize SDL. SDL init, SDL underscore init everything. All caps. It gets it all fired up. Next thing we need is a window. We call SDL create window. We give it a title. Position. I'm going to put all of my arguments on separate lines here. You do not have to do this. This is just so you can see it, because my window is blown up, zoomed in. The next thing we need is a position. So you can do SDL underscore window position. You've got some options. You can go centered. You can go undefined. You can just, put a 0 in here if you want to, and it'll be in the top left corner. We'll go undefined. That's just for the X. So we'll have to do the Y as well. And our window needs a width and a height. What do we put here? 1360 by 768 Ultra HD. And last argument, no. You could do borderless and stuff like that. If you wanted your window to have no border, just like you know, typical loading screen, splash screen, you can do that right there. This flag controls that. There's a handful of options there. Or you can go maximized or minimized. That's what that flag does. Full screen, stuff like that. Next we need a renderer. And this is how any SDL project is going to go. You're going to initialize everything. You get a window. You get a renderer. And we'll do a poll event loop. And that's the core of just about every SDL program I've ever written. Renderer takes your window, a -1, and some flags. SDL renderer accelerated. So that's the basics. We'll create a bool here, running, while running. This is our main loop. And then we have a poll event loop. We need an E. The poll event, you pass your event in. It's going to set whatever event is next in the queue to this E so we can read it. And poll event. Does everyone understand this? I know whenever I'm typing and you're following, it's easy to get into this mode where you're like a zombie. You're just typing when I'm typing. You have no idea what you're doing. You want to avoid that. You want to understand what you're doing. All right. Hopefully this is clear. I went over that. Now what did we just do?
We set it up so we can close our stuff out. Eventually. So we can step.
Well, the program runs in a loop. Any game or any program, almost any program runs in a loop. Same thing over and over again. Look at Visual Studio right now. It's in a loop. It's displaying what I've typed. It's flashing a little cursor at me, and it's waiting for input. It happens over and over and over again. Programs run in loops. Okay? This is our main loop. This is where everything happens. That's why the variable that this loop hinges on is called running. While the program's running, this is what we do. The event is going to check for events. That happens in a loop. You can have multiple events, like moving the mouse, clicking the keyboard, joystick input, file stream input, any events are handled right here. And so like the basic program does input, and it does update, and then it does draw. Input, update, draw. And that happens over and over and over and over again. That's what we set up. This is like the core of any program, just about any program. So what are some things that would go in update in Snake? Just in general.
Your
Pickups and
moving, yeah.
Moving, definitely moving. Collision detection has to happen every loop. Score gets updated. Some games, artificial intelligence would have to be updated. Like if this were Pac-Man or Halo or something like that, right? We would have everything that is physics goes into update. And then we draw, right? We draw the board, we draw the snake, we draw the pickups, we draw the score, draw all the good stuff that we just updated. So try to wrap your mind around that. This is how programming works. This is how almost any program works. Input, update, draw. All right, what's our mission? What are we doing here? We created a window, we created a renderer. We need to create an instance of a snake, a wall, and a pickup. We got a main loop, a pull event loop. All right. In our draw, we're going to clear the screen. So we need to set like a background color that we want to clear our screen with. And normally you're just going to go with the dark gray right here. So I'll go 10, 10, 10 to 55. And then here we draw all the things. And then we present. Oh yes, very good. Can't just set the draw color and not do something with it. And then we present. Let's see if this even works. I'm going to see if it works. Y'all should not see if it works. Oof. Error. Main must return a value. Close C. Return 0. One more time. Bam! We got it. Let's add the quit event like we did before, just so that this thing will quit. So for pull events, we're gonna have a switch. It's gonna work on the e.type. So our case here is SDL_quit. All caps, and at this point it would be proper to destroy the window and call SDL quit and all that stuff, but if you're just vicious, you can type return 0 right here and it will effectively do the same thing. But if you want to be proper, we'll call SDL quit. It's going to be really proper. Before you do that, you like destroy the renderer, destroy the window. We're tearing down in the order that we built it. Right, this is the opposite of how we started this. This is the opposite of a init, opposite of create window, opposite of create renderer, which is destroy everything and then return 0. I like all that. That works. We need a snake. We gotta get a snake and a wall. Snake, a wall, and a pickup. Right? The pickup's gonna be an egg, I think.
There's like an egg, there's like a pickup or something.
Like a Chevy, or what did you have in mind?
No, it was like a
Power speed of because I mean there's an egg and a pickup.
yeah, there is egg and pickup.
There's an egg, pickup, and power.
Where's egg?
It's
Right.
the first,
Who wrote this lab?
is
You.
pickup is derived from pickup derived egg and power up.
Who ever heard of a power up in Snake?
I know, right?
Okay.
Do you want other things to come in? Power up? Bigger eggs.
Hey, for some reason, I don't have the. It's not showing the wall header file. So when I try to add class wall, it says it's already instantiated, but it doesn't show in the folder and in there in Visual Studios.
I don't know. Okay, we're gonna add the pickup. I'm going to do the egg. So for the egg constructor here, I'm going to write a definition for that. We create the egg. I'm gonna want a constructor like we had for our generic object. So egg string texture name we'll define that. Or what you can do is you can just call actually even faster, we can just call the constructor we already wrote object texture name. Parentheses. Why doesn't it like that?
Indirect, non-virtual baseball. I don't know what half resolution.
Indirect non-virtual class is not allowed. indirect. I wonder if that's because I'm going through pickup.
I think you had to derive from pickup first, then derive to object.
I derive from pickup. I think that's why it won't let me use my object constructor. So in pickup we would have to have something similar.
It works. I found out how to fix it. You have to put class after the colons. You put public object and then a comma.
That should already have been there.
And the header
Right,
bar.
right here?
Yeah, no. Before the public object, you put class pickups, then public pickups, and then comma public object. Wait, are you in the pickups? Wait. Cut. I'm in the egg. Like in the egg.
You're
okay.
in the egg.
Yeah.
Alright.
Okay. Class egg, public object, comma, public pickups.
From here?
Yeah, on
No, you
top.
don't want to do that. You don't want to do that. That would be multiple inheritance from a class that you're already inheriting from.
Oh. Well, I had to work doing that.
It might compile, but you have a mess.
Just because the red squiggle's done doesn't mean it's working.
Doesn't mean it's
Just
working.
means you made it happy.
Where did I find that out?
Yeah, don't do that. We're already deriving from object.
Okay.
But in pickups, we'll do the same constructor here, and on this definition, then we can call the object. And pass it the texture name. And that should work. So you can't jump 2 levels. That's what I was trying to do. I was trying to jump up 2 classes, and you can't do that because egg comes from pickup. We can call pickup, and it can call object. So we have to sort of pass it up the chain. All right, back at object, or back in main, I should say. Let's see if we can get an egg. Where would you put the egg? Like, where would you create the egg? Inside the chicken. Where is the chicken? I'm gonna have a fun assignment for you. You're gonna have a chicken in class and an egg class. All right.
Chicken egg cutter.
Chicken goes in the egg goes in the chicken, and you're gonna try to get that to compile.
We need times first.
It's more difficult than you might think. No, where do we create the objects?
In the after the
loop.
poll move.
In the loop?
In the update.
In the update. We create objects in the update? Think about it. How many times is this loop gonna happen?
Until we call the stop.
Yeah. Uncharted number. How many snakes do we need?
Just one.
Right, so that's why we would not want to create an object in the loop. We only need one. So before we get into the loop, we'll create our objects. It doesn't see egg.
You gotta go
GG.
to the pickups.
GG. What?
You gotta go to the pickups.
We have to include egg. If we're going to include egg, egg includes pickups, which includes objects, so we don't need object anymore. We just need egg. Don't mind IntelliSense is dumb.
Okay, so it's what?
There's the egg. We'll also need the snake. So player, snake. What was the other one? Wall. 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 So we'll have to include those two.
I can't include wall because even though it says I can't make it, when I'm adding it, it says it's off because I can't include wall.
Is this the same problem you had a minute ago?
Yeah.
All right, we'll come back to it later. Those are objects. Let's see if we can draw the egg. You need an image for this egg in your project. Who does not have an image? I don't have one either. It's okay.
I don't
No, 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 no. That's a good egg color.
It's the same.
Who's that?
It's a very high resolution picture of a
Dude,
That's what we should make our eggs, dude.
That is a very high resolution picture.
3200 picture of a geo.
That looks so puppy. Looks like a class.
The SB says PNG, right?
Yes. That's pretty good.
Is there a maximum on the PNG size?
Yeah. A 20 by 20 it should be good.
20 by 20?
That's what I'm doing.
When you do all these things, they go down.
How do you make it go down?
Just tell them to go down.
How do you dodge and burn?
I know how to crash and burn. Don't do it right now.
Hmm.
Really transparent.
Yeah, that's exactly what I just sounded. Great.
Oh my god, I can't use water. I have two header files that won't show both player and wall. And it says it's already been in there.
It's kind of like.
I don't even know what happened to
This
it.
dude, it's like paradise.
That's probably the best egg I've ever seen.
I'm screwed, so see, someone else has to sign
Save as egg.png. I need to make sure this eventually ends up in my project.
Just get 20 by 20.
Yeah, all the like that's what we use. That's the resolution. Yeah, like inside the studio. Yeah, so whatever that is gonna be a bigger release.
Does everyone have their egg file?
Yes.
Okay, we're going to use our constructor that we just built and chained up. So we'll put egg PNG in there. Now, if you did not name yours egg PNG, don't type that.
So it's not working.
Every time, every single time.
You know what? That doesn't surprise me.
That will get it on the screen. How do we, no, that won't get it on the screen. That creates the object. How do we get it on the screen? How would we draw it? What? How do we draw it?
Egg.draw.
Egg.draw.
Oh.
Maybe this time.
Oh, what is allowing to draw? Egg.
That didn't work.
You didn't code it in the draw function.
What?
Did not code it in the draw function?
No, we have a draw function, an object. Remember, the inheritance passes it down all the way to the egg.
Well, apparently my draw function doesn't work.
Mine doesn't either. Does anyone know why? Think about it. Yours does?
I mean, I had more code on
You cheated.
it. It's also flashing into
No, the reason mine is not working, I don't know what witchcraft he's doing over there, but
Draw the
this renderer is what we're using in our draw function, and that pointer has not been set yet. So, in order to have that pointer pointing at this renderer that we create in main, we need to do something before we create the egg, because that uses the renderer. We need to say object ren equals ren. Why is it angry? Oh, it must be static. Must be static. That makes perfect sense. We don't want a renderer for every object. So, static. Renderer ren, go back to main. We set it equal to this renderer. Maybe this time.
Nope.
Crash and burn. It's angry about our static variable. These things have to be initialized. Y'all remember that? No? This is going to be on the test. I'm putting that on the test for sure. Right? If we declare a member static variable, we have to initialize that in global space. So in object CPP is as good as any. I say that. We probably should do it in main. Up in global space in main, that way this happens before this. We can say SDL underscore renderer pointer. You give the data type, and then you give the class, and then you give the name, and you initialize it.
So don't do the inline initialization.
You can do that. You can do it that way too.
You just gotta make sure you're on the
You just got to go in there and set it to 17. So maybe this time.
It's not gonna work.
Hey! There's an egg. It's beautiful. Alright, there's an egg on the screen. The last thing I want to cover is update or controls. And this is how you're going to get some keyboard input. Now, what I'm about to do is not how you do the lab. You need to read the instructions on the lab. For the lab, this has to be carried out in the objects update function. I'm going to do it in line here. I'm going to make you think about it. We're going to get the state of the keyboard. Now, there are poll events for keyboard input, and that is great for typing. All right, if you want someone to be able to type in your game, you're doing like some word type game, or what are those horrible games called? Visual novel or something like that. You would do that up here. If you want to type, that would happen in the keyboard event. But in most gameplay, you want the response to be instant. You know, if I push a key right now, typing, there's a pause before I get that follow-up. That's terrible for gameplay. We don't want that. So in order to bypass that, we just get the state of all the keys. They are either pressed or they are not. So to do that, you're going to declare, actually I don't remember the data type, so I'm going to be lazy and type auto. Keys equals SDL underscore get keyboard state. And you pass that null. I'm going to change the word keys to key. And there's an array of keys, all the keys on the board, and it's an array of bools. They are either pressed or they are not. And that is what is returned here. Okay, so now if you want to get some specific key, you can say if key, and because it's an array, we use brackets, and because there are enums, we can type which key we want. We can say SDL underscore scan code underscore, and then you pick the key. So let's say if I want it to go right when I press right, just type right. And then how would I update my egg?
Position.
Egg dot x doesn't have dot x. Dot rect, that will give us a dot x. Plus plus.
That'd be pretty fast.
It would be blazing fast, wouldn't it? We're gonna have to deal with that, but let's build up to that point where we realize we're gonna have to deal with that. We'll write the same thing for left. So be lazy there, copy and paste left, and then instead of going plus plus, we go minus minus. And there's our update. Written out of place, but that's the code, that's the mechanics. Check out the keyboard, go to a specific key. If it's pressed, we do things. Look at that. It's amazing.
Strange on the lane school. Looks very weird on the lane school.
Yeah, it's choppy on land school. It's so bad, but it works. It should work.
Looks like I'm trying to think about
Yeah, it's not that. Well, there's just many problems.
Many problems.
Oh my, I don't even know what's going on.
So much problems. Okay, a better way of dealing with that speed issue, since we can't go any more, or we can't go any less than 1 when we're dealing with integers. If you try to go 0.5 or 0.20, just trim it off, and you won't move anywhere at all. So if you try to say, plus equals 0.1, you get nothing. The way we deal with this, let's go to object. And we'll add a float x and y. Float can handle a point something value. So then instead of saying the rectangle equals that, I will say the x plus equals something. But then it would not move the rectangle. So to move the rectangle, you say rect.x equals egg.x. This extra float in the middle allows us to keep our precision, and then the egg will move over when it reaches that point. Tell you what, instead of speed, for right now we'll just do 0.5, so it'll go about half as fast as it was. And then we'll do the same thing below. So for we're doing minus equals. Go left that way. Does that make sense? Does it work? Does it go half speed now? It snaps to the right or to the left side because I didn't initialize those floats. So that was bad form on my part. These should be set to 0 so it doesn't snap. It still snapped. Why did it snap?
Because when they said 100 or 100, the rectangle.
Yeah, so it should be 100 instead of 0. Right, good call. And we'll fix that later. That's not the way you want to code, but that's the problem. Did y'all hear what he said? Because we set the rectangle to 100. So really, for these to line up, they would also have to be set to 100. And there you go. You have smooth motion at half the speed. The other problem that we have now, this speed is computer dependent. So if you're on a potato, it's going to go really slow, and if you're on a fast computer, it's going to go really fast. That's not good either. So there's one more thing we have to do to make this time dependent. I'm going to make 2 floats. Current and delta. We're going to use these 2 variables to keep track of the amount of time that elapses over the course of one loop. This is going to be on the order of milliseconds. At the beginning of every loop, we're going to calculate how much time has passed. Delta equals however much time has passed since the game started, since however much time we measured last loop. We're going to use current to measure or to keep track of what we did last loop. The function is getTicks.
Look at us.
You want to put that in parentheses and then divide by 1,000. That puts it up in milliseconds instead of seconds, or vice versa. I may have said that wrong. I don't know. And then current equals SDL_getTicks. It kind of like sets. This measures the difference since the last loop. The first time the program runs, this will be wrong, but that's fine. But from there on out, it'll be fine. And then this sets the stopwatch for the loop. So if you want to know how that works, that's how it works. Now, everything we do that's time dependent has to be a function of delta. So our egg down here, instead of times equals 0.5, it's going to be a much bigger number. It's going to be something like 500 times delta. Or egg.speed times delta. I think we initialize speed to 0, so this guy won't move, but let's go fix that. An object CPP, instead of setting our speed to 0, let's set it to 500 or something like that, and we'll try our egg out again. Now what we have is the smoothest egg motion known to man. And it's time dependent, so you can run this on any computer and it will behave the same way. As long as the computer is not so slow it can't keep up. But where's main? Where's main? Here we go. That's how you do keyboard controls. That's how you put stuff on the screen. Now, I did it all wrong. I told you that from the beginning. This stuff needs to happen in each object's update function, and then you need to call update in main. So here, what I should have is egg.update, snake.update, wall.update, and then this stuff will take place in the update function. Yeah, you can copy and paste it, but it's not going to work without some modifications. All right, so that's what I'm going to leave you with.